Hey everyone, welcome back to Age and Education channel. Today we shall continue with the chapter Heat. So as a part of this, we shall elucidate further on the varied processes of heat transfer. And what are these processes? I think I have just mentioned, right? I did not explain, but I have mentioned that we will look into these processes called as conduction and convection, then radiation, right? So conduction, convection and radiation are the varied processes that we have to understand, learn the differences and find out the mode of heat transfer that's happening, right? Next, we should also look into change of state. Okay. So now the first topic that we will be covering today is conduction. So as I have mentioned, conduction is one of the processes of heat transfer, right? So it is a process of heat transfer. So what happens here and where is it applicable? Conduction is applicable in solids. Why only in solids? It's because in solids the molecules here are tightly packed, right? So what happens? These molecules, in order to transfer the heat from one molecule, from one part of the object to other part of the object, these molecules as such won't move. What is it? The molecules here or particles of the medium here won't move at all. Particles of medium do not move. So how will this transfer of heat happens then? It is that whenever you place any object, you consider this solid object, okay? Imagine that you have put it in the hot water, very hot water, right? So you are exposing only this part to heat. So what happens here? The molecules here or the particles of the this object here will start moving vigorously, right? And while they are moving so vigorously, they tend to hit the or touch or strike the molecules beside them or the particles of the medium beside them. So eventually they transfer some amount of heat to the other molecules beside them, right? And then again this process continues. The same thing happens and happens till there is an equilibrium of temperature reached. That is, when this part, the heat is transferred from here to the colder part too, and all the object will attain the thermal equilibrium or will have equal amount of heat, right? So this is about the conduction, right? I hope you all got it. What are the important things that you have to see here? One thing you have to remember is that heat flows from areas of high temperature to low until thermal equilibrium is achieved, right? You say that conduction is applicable to solids because here the molecules are tightly packed, right? And apart from this, the other thing that is important here is that this rate of conduction is not uniform in all types of solids, right? It varies depending upon the nature of the object that is that you are considering, right? So it actually depends upon thermal conductivity of the object. What is it? Thermal conductivity of the object. Okay. So if you take good conductors, then the heat transfer will be efficient. But if you take bad conductors, the heat transfer won't be efficient. Okay, I'll further let you know in the next slide. So if a body has more thermal conductivity, then it means that it can transfer the heat more efficiently. It means more better, right? More thermal conductivity implies more better transfer of heat. Okay? More better transfer of heat. Right? Now, it means that if we can sort the materials to be having more thermal conductivity and less thermal conductivity, then we can say that good conductors will have more thermal conductivity, right? More thermal conductivity, whereas bad conductors or insulators will have less thermal conductivity, and that is the reason they can transfer the heat better, right? So what are the examples of good conductors? Yes, you all know metals are the examples of good conductors, right? And how about the bad conductor? Air can be considered as classic example of insulators, and that is the very reason we use it in winter clothing to protect ourselves from uh, this one, right? Cold, sorry. Apart from that, I also want you to get to know about this concept of igloo. I think you all have studied about igloos in your lower grades, right? So even this igloos will work on this concept of bad conductors not allowing the heat to be transferred efficiently, right? And apart from this, what else we have to look into is, we will get into convection next, and after that we will get to talk about radiation. Okay, so next is convection. So what is convection? Convection is the process of heat transfer which is seen in liquids and gases. So what is the difference between conduction and convection? In conduction, what did we mention? We mentioned that there won't be any movement of the molecules. Molecules won't move in conduction, right? Won't move in conduction. But whereas in convection, you can see that there will be molecular movement. Molecules itself will take the work and responsibility to actually transfer the heat, right? So molecules move, they themselves move to transfer the heat energy. Okay, this is the primary difference between conduction and convection. We will see the dynamics as how this works. Okay, molecules move to transfer the heat energy is called convection here, right? So what happens if you take some liquid, right? Take some liquid and put it on the burner. Okay, so initially this molecules get heated up, right? Once they get heated up, they go up. Okay, and the colder particles, colder molecules come down. Okay, and this process continues, this circular process continues such that the entire liquid will become equally hot. Okay, this process is called as convection. Here what happens is that when the molecules get heated up, they become less denser, right? So when the molecules get heated up, they become less dense, and so they float, right? It means that they rise up, they rise up. So the warmer molecules go up, and the colder molecules, being more denser than hotter molecules, they come down, right? So the less denser molecules go up and the more denser come down, and as less denser molecules, it means that they are warm, the warm particles go up and the cold particles come down, and the circular motion continues to be done till entire liquid attains the same temperature. This is how the transfer of heat energy takes place through convection. And very important global processes, not only global process, but local things will also happen because of this convection. They are popularly known as what? Land breeze. You have already studied about these, right? Land breeze, sea breeze, right? Wherein because of this temperature difference between hotter area and cold area, and because of the differences in the pressures, the breeze will blow either from land to sea or from sea to land. And the assignment that I am giving to you is just check on what is the meaning of land breeze and sea breeze, because it's important that you yourself learn to check out the things. Okay, this is already, I think, in 6th grade or something, you are already done with this land breeze and sea breeze concepts. Okay, just go and check. And also trade winds also happen because of this. Okay, if at all you are not able to get through it, let me know in the comments. I will explain to you what is this land breeze and sea breeze. I'll make a separate video for it, and I will mention about land breeze, sea breeze and the trade winds. Okay, so we are done with the topic what? Convection. And what are the applications? Land breeze, sea breeze, trade winds, right? Now the other thing that we want to look into is radiation, right? So what is this? What is the next topic that we have to cover? It is radiation. What is radiation? Radiation is yet another process of heat transfer, right? In what way it differs from conduction and convection? It differs in the sense that here there is no need of having any intervening medium, right? Of having intervening medium. So what happens is that when there is one hot body and cold body, okay, and consider there is no intervening medium in between them, even then the heat is transferred from the hot body to the cold body, and this process is called as radiation. Here what happens? This transfer of heat, then if there is nothing, how is it getting transferred? It is transferring through electromagnetic waves. What is it? Electromagnetic waves. So we can say that transfer of heat, what is it? Transfer of heat through electromagnetic waves is called as, through electromagnetic waves is called as radiation, right? It's called radiation. And what is the most important thing that you have to remember here is that it does not require any medium, right? So just can you think of any example for this? Yes, the heat received by earth from where? From sun. Heat received by earth from sun can be considered to be an example of radiation, right? And this is also like conduction and convection is so important. Okay, now with this you can even say that dark colors are good absorbers of radiant heat. Okay, and light colored objects reflect the radiation to the most. Okay, and with this you have many applications too, right? Like how you prefer wearing some colored clothes in some months, some seasons, and some color clothes in other seasons. Like as dark clothes are good absorbers of heat energy, right? For this, in just think of as in which season you prefer to wear a dark color clothes. Tell me, what did I say? They are good absorbers of heat energy, right? So you prefer to wear dark clothes in winter season, right? Because they are good absorbers. Dark colored clothes in winters. Whereas light colored clothes are what? They are good reflectors, right? Light colored clothes are good reflectors. So you will use these in when? During summers. Okay. So dark colored clothes are used in winters and light colored clothes are preferred in summers, right? So you can see everything is so interlinked, right? You will have to understand various nuances of all this, then you will like your brain will retain everything. Okay, about we are done with this radiation too. Now we have to see change of state. Okay, then we can wrap up this chapter. Now change of state. What is this? What is change of state? I know that you know how does matter exist? What are the states of matter? Solids, liquids and gases, right? There is also fourth state called as plasma, but let us not get into it. Okay. So first of all we will look into solids, liquids and gases. So whenever we give heat to solids, it will turn to liquids, right? And when you supply again heat to liquids, it will turn to gases, right? And in some cases, if you supply heat to solids, instead of getting to the liquid stage, it can directly go to gases too. Okay, so we will look one by one, right? So the temperature at which solids turn to liquids is called as what? Melting point, right? Now, what is the temperature when liquids turn to gases? It is called as what? Yes, boiling point of a substance, right? So here what happens is that, consider this amount of solid, right? When you are supplying heat to it, then the heat will be taken by the solid till it reaches the temperature of melting point, right? It keeps on taking the heat till it attains the temperature of melting point. And then what happens when it reaches this stage? Then the solids will start turning into liquids. At this time you don't find any increase in the temperature, right? The temperature is maintained constant at melting point, and the solid will be like it will be in the process of getting itself converted into liquids, right? So again I am telling you, don't get confused. Okay, so when you take a piece of solid and you supply heat to it, continuous heat, right? So this heat energy is taken by this, and its temperature keeps on increasing linearly, right? It increases till it reaches a melting point. Okay, when the solid reaches the melting point, then it starts getting converted into liquids, right? So during this conversion, at this point where solids after reaching melting point gets converted into liquids, at this time whatever heat you are still supplying, that won't increase the temperature of this solid anymore. It is because solids are now in the process of getting converted into liquids, right? So all this is like what do you call, the solid will wait till it reaches the melting point. It keeps on taking the heat till it reaches this point, and after reaching this point it will say that okay, now I cannot stay in this state anymore, I have to become liquid. Okay, and while it is becoming liquid, when it has reached melting point and it is in the process of reaching the liquid, it will say I am not going to increase my temperature anymore. You have to wait for it. Wait for the next stage. Okay, so what happens in the next stage? Let me change this page. Here in the next stage. So what happened? First we have seen that solid has turned to liquid, right? And the temperature here is melting point. Now again you continue the process of giving more heat energy to it. So again the same, this liquid will keep on taking the heat till it reaches what? Yes, boiling point, right? So when the entire liquid reaches the boiling point, then what happens is that this liquid, after it reaches the boiling point, it starts converting into gas, right? So at this point again, how much ever you supply, when after reaching boiling point, how much ever heat you supply, the temperature won't increase anymore, because it is in the process of getting converted into gas, right? So this is how the change of state happens. Okay, you will consider this melting point, and what else is important for us? Melting point and boiling point, right? Then just think of as what will be this melting point and boiling point of water. So what is the state, the solid state of water? Yes, it's ice, right? And liquid state of water is water, right? And the gaseous state is water vapor. Now tell me, here what you will get here? Here it is melting point, right? And here it is boiling point. So what will be the temperature of melting point? When will the ice start getting converted into water? It is at 0 degrees centigrade. And what is the boiling point of water? It is 100 degrees centigrade, right? So this is how you can know as what is the change of state and everything else. Okay, and there are also some other things like latent heat of fusion and latent heat of vaporization. Okay, it is latent heat of vaporization. Okay, these are the terms associated with this melting point and boiling point, right? It is a number, a heat energy per unit mass, right? Per unit mass that is required to change the state of a substance from solid to liquid at particular temperature and pressure, right? So all this is not so much important, but one thing you have to remember is that latent heat of fusion is associated with melting point and latent heat of vaporization is associated with boiling point, right? It is just what it is in simple terms, we saying that we need this much heat energy to convert unit mass into water from ice, or to convert a unit mass of solid to liquid state, right? So it is like a index, it's not even index, it is an easier way to understand as what is the latent heat of fusion for some substance and comparing it with other substance. Okay, so don't get confused with it, it is not so much important, you can skip it, but just remember that latent heat of fusion is associated with melting point and latent heat of vaporization is associated with boiling point, right? Okay, so we are done with the chapter heat. I hope every one of you got it, and if at all there is anything that you didn't get, please don't hesitate to comment in the comment box, and I'll surely make another video explaining the things, or I will answer it there itself, right? Okay, I didn't stress more on this latent heat of fusion and latent heat of vaporization as you may not need it at this stage. Okay, if you want to know about this too, again comment it, I will get into that details too. Okay, see you, bye.